Yard plan. Route section plan is prepared according to standard of interlocking plan. In bigger yards, yard is divided into different zones. Each zone is considered with different signal routes. The route section plan shows the entrance and exit buttons with their designation at their geographical location. In route section plan, route sections are marked in bold lining and sometimes with different colors, and overlaps are marked in dotted or shading lines. This facilitates their easy identification route sections from overlaps in big yards with many route and signals. The buttons are represented by small circles in the plan. Zone. In bigger yards, yard is divided into different zones. Each zone is considered with all possible signal routes. Signal route. Possible signal movements with main signals and all subsidiary signals in the station limit will be considered. In signal routes, all possible movement on main signal and subsidiary signal in station limit. Subroute. It is part of signal route. In one subroute, only one movement is possible at a time. The entire layout is divided further into a subroute, considering the requirements of rigidity or flexibility of the yard movements, that is, conflicting measurements, simultaneous movements, and sectional route release as the case may be. Subroutes are numbered as per the number of any one of the points which exists in it. If there is no point, such subroute will be numbered as per the signals controlled by it. Subroute which includes one or more points are so formed by combining route sections, so that only one movement is possible over that subroute at a time. This is ensured by using a common subroute locking relay URLR. For a crossover point in which parallel movements are possible, there has to be two subroutes. Each subroute is further divided into route sections, each route section usually giving certain specified setting of points. The straight movement over a subroute requiring points in normal position is called A route section, and the diverging route requiring points in reverse is called B or C or D route section. A subroute can have one route section or more number of route sections. Route section. It is part of subroute. Route section will define concerned setting of points in the subroute. In route section, planned route sections are marked in bold lines, preferably with different colors. Overlap. Overlap is the adequate distance kept to ensure safety. It is part of complete signal route. Setting of overlap ensures correct setting of points falling in the overlap. Overlaps are numbered as per the signal numbers beyond which they fall. These are required to be set along with the route for main signal in rear. Many places more than one overlap are available to choose from. In the above layout, signal number 5 has only one overlap, whereas signal number 6 has two overlaps. Where there is a choice of overlap, a separate overlap setting relay is provided for each overlap. For selecting the required overlap, a separate route button is provided. In case of non-route setting type of relay interlocking, separate overlap button is not required, since points in the overlap are to be set individually to the required position. In route section plan, route sections are marked in bold lines, preferably with different colors, and overlaps are marked in dotted lines. This facilitates their easy identification from one another in big yards with many routes and signals. The buttons are represented by small circles in the plan. Each overlap is provided with one interlocked relay called OVZ2URR by OVZ2UNR. Latching of reverse coil indicates that the relevant overlap is set, and this relay will lock the overlap points. Case number 1. On point number 101 between signals S1, S2 and S3, the possible route resetting and signal movements are shown in below table. At any point of time physically, there will be only one movement is possible over point number 101. This satisfies the condition for considering the movements over point 101 and the route settings to be in subroute, as in one subroute only one movement is possible. Locking of normal route setting for point number 101, normal by subroute. Lock relay URLR will lock other diversion route setting for point number 101 reverse and vice versa. This subroute will be named after the point number it is controlling. In this case, it is 101 subroute. In this 101 subroute, there are two route settings, that is 101 normal route between S1 and S2 and 101 reverse route between S1 and S3. These two routes are subdiversions of 101 subroute with definite settings of point or points. The route set with 101 normal will be one route section of subroute 101 named as 101A route section. The route set with 101 reverse will be another route section of subroute 101 named as 101B route section. Now the subroute is known as 101A by B subroute. Point number 101 subroute is 101A by B. Route sections are 101A with point setting 101, normal with track circuit 101AT, and 101B with point setting 101 reverse with track circuit 101AT. The route sections are marked with solid lines. Route section marking will always start from the block joint of first track circuit controlling that point or points and ends at last track circuit block joint controlling that point or points, as the case may be. Sometimes adjoining track circuits also added in the route sections, particularly towards home signal. Route section names will be written generally in a box attached to the route section demarcations. Route section name should be written as such a place where it is exclusive for that route section and not at common demarcated portion with other route sections of that subroute. Number 2. On point number 101 between signals S1, S2 and S3, the possible route setting and signal movements are: at any point of time physically, there will be only one movement is possible over point number 101. This satisfies the condition for considering the movements over point number 101 and route setting to be in one subroute and named as 101A by B subroute as earlier. Point number 101 subroute is 101A by B. Route sections are 101A with point setting 101, normal with track circuit 101AT, and 101B route section with point setting 101, reverse with track circuit 101AT, 101BT as shown in the table below. The route set with 101 normal will be one route section of subroute 101A by B named as 101A route section, and the route set with 101 reverse will be another route section of subroute 101A by B named as 101B route section. Over point number 101 and 102 between signals S1, S2, S4 and S6. The possible movements are shown in the table. At any point of time, there will be only one movement is possible over the point number 101 and point number 102. This satisfies the condition for considering the movements over point number 101 and point number 102, and the route settings to be in one subroute and named as 101A by B by C. Point number 101 and 102 subroute is 101A by B by C. Route section 101A with point setting 101 normal with track circuit 101AT, 101B route section with point setting 101 reverse and 102 normal with track circuit 101AT, 101BT and 101C route section with point setting 101 reverse and 102 reverse with track circuit 101AT, 101BT, 101. One subroute requires one route group, and one route group can take care of two route sections as per the relays available in the route group, namely A URS by UNS, A DUCR and B URS by URS, B DUCR and other common relays, URLR by UNLR, UDKR, UYR1, UYR2. Since we have three route sections in this case, we need separate CURS by UNS, CDUCR mini group relays placed in the relay rack and wired with the relay group and its common relays required for this route section. On point number 111 between signals S1, SH11, SH3 and S12, the possible movements are in this case, at some point of time there will be two movements possible over crossover point number 111 with 111 in normal position, serial number 1 and 3. Hence, the movements crossover point number 111 cannot be in one subroute. Each simultaneous parallel movement possible over point number 111 requires one subroute each. Point number 111 subroutes are 111A by B and 111 small a. In 111A by B subroute, route sections are 111A with point setting 111 normal with track circuit 111AT, 111B route section with point setting 111 reverse with track circuit 111AT, 111BT. In 111 small a subroute 111 small a route section with point setting 111 normal with track circuit 111AT. One subroute 111A by B will be marked as earlier with two route sections 111A towards main line and 111B towards diversion line. Now the new subroute will be named after same point number but with one route section with point number 111 normal. This route section is named as 111 small a as it is also with point in normal condition, and the subroute will be 111 small a. In some railways, this route section and subroute are named as 111 small z. Number 5. Over point number 101 and 102 between signals S1 and S2, S4, S6, the possible movements are shown in table. At any point of time, there will be only one movement is possible over point number 101 and point number 102 together. This satisfies the condition for considering the movements over point 101 and point number 102 and the route setting to be in one subroute and named as 101 A by B by C subroute. Point number 101 and 102 subroute is 101 A by B by C. Route sections are 101A with point setting 101 normal and 102 reverse with track circuit 101AT, 102AT. B route section with point setting 101 reverse with track circuit 101AT, 101BT and 101. And C route section with point setting 101 normal and 102 reverse with track circuit 101 AT, 102 AT, 102 BT. Number 6. Using same yard of case number 5 with sectional route release facility. Over point number 101 and 102 between signals S1, S2, S4 and S6, the movements are provided with one subroute 101 A by B by C as discussed at the case number 5. Consider the table. In this case, for the main line signal movement, route section 101A and subroute locking relay 101 URLR has to set for locking the points 101 and 102. Point number 102 will be released only on complete arrival of the train beyond point number 102 and 102 AT track circuit clearance. This will not cause much delay in case of small yards, but in case of major yards, when a point has been cleared by the train, it should not be held further for clearance of another point or points and thus the track circuits. This will cause delay in clearing the other movement. Example, S4 to S1 movement. If at that time 102 AT track failure take place for any reason, point number 101 release will be delayed further. This will affect the flexibility of yard movements. In case major yards, sectional route release feature has to be provided to the full extent. With full sectional route release feature, the same yard will be redesigned with two subroutes as shown. For utilizing sectional route release arrangement over these points, track circuits should be provided separately for each point, and each point may be provided with separate subroute with two route sections in each subroute, so that on clearance of each point by the train, release points could be used for other movements as permitted by the station interlocking. One subroute 101A by B will be marked with two route sections 101A towards main line and 101B towards loop line number 1. Another subroute 102A by B will be marked with two route sections 102A towards main line and 102B towards loop line number 2. Point number 101 and 102 subroutes are 101A by B and 102A by B. In subroute 101A by B, route sections are 101A with point setting 101 normal with track circuit 101AT, 101B route section with point setting 101 reverse with track circuit 101AT, 101BT. In subroute 102A by B, route sections are 102A with point setting 102 normal with track circuit 102AT, 102B route section with point setting 102 reverse with track circuit 102AT, 102BT. Case number 7. Over point number 101 and 102 between signals S1, S2, S3 and S4, the possible movements are in this case, at some point of time, there will be two movements possible over crossover points number 101 and 102 within normal positions, serial number 1 and 3. Hence, all the movements over crossover points number 101 and 102 cannot be in one subroute. Each simultaneous parallel movement possible over point number 101 and 102 requires one subroute each. One subroute 101A by B will be marked from S1 with two route sections, 101A towards main line and 101B towards diversion line. The second subroute 102A by B will be marked from S3 with two route sections, 102A towards main line and 102B towards diversion line. Point number 101 and 102 subroutes are 101A by B and 102A by B. In subroute 101A by B, route sections are 101A with point setting 101 normal and 102 normal with track circuit 101AT, 101B route section with point set 101 reverse with track circuit 101AT, 102AT. In subroute 102A by B, route sections are 102A with point setting 101 normal and 102 normal with track circuit 102AT, 102B route section with point setting 102 reverse with track circuit 101AT, 102AT. Number 8. There are some route sections without points in them to control. In single line section, this route section will be provided between home signal and advanced starter signal. In case of double line section, these route sections will be provided after home signal and after advanced starter signal. These route sections are provided for route holding and will be helpful in simplifying the indication locking proving while releasing the route sections. While route releasing in each route section, the signals, their aspects and their controlling relays on both sides of the route section are proved in normal condition. Route sections without points are numbered as per the signal, that is, in case of double line, are signals, that is, in case of single line, controlled by it. This single line section example shows one route section without points falling between the home signal S1 and last stop signal S3 is numbered by S1 by 3 URS since it is controlled by the signals S1 and S3. This double line section example shows two route sections without points. One route section falling after the home signal S2 named as S2URS since it is controlled by S2 signal. Another route section falling after the last stop signal S15 is named as S15URS since it is controlled by S15. Number 1. Preparation of route section plan for the given signal plan with rigid interlocking. Route sections. In the above signaling plan, start from left to right. There will be a route section without points between up home signal S1 and down last stop signal S3 named as S1 by 3 URS. Click on case number 8 for explanation. Similarly, another route section will be provided between S19 and S15 named as S15 bar S19 URS. Click on case number 8 for explanation. Over points number 101 and 102 at any point of time, there can only be one movement between signal numbers SH2 and signal number S4, S5, S6. So, there can be one subroute named as 101 A by B by C with three route sections named as 101 A, 101 B and 101 C. Click on case number 3 for explanation. Similarly, over point number 107 and 108 between signal number SH16 and S12, S13, S14, there can be only one movement possible at any point of time. Hence, these 2 points will be controlled by one subroute 107A by B by C with route sections 107A, 107B, 107C. Click on case number 3 for explanation. Overlaps. Down home signal number 19 will have overlaps marked as below. For S19 to main line, only one overlap from S4 to S3 named as OV4. For S19 to loop line number 2, only one overlap from S5 to S3 named as OV5. For S19 to loop line number 1, this movement will have 2 overlaps from S6 to sand hump with point number 101 normal named as OV16. From S6 to S3 with point number 101 reverse named as OV26. Similarly, up home signal S1 will have overlaps as marked below. For S1 to main line, only one overlap from S14 to S15 named as OV14. For S1 to loop line number 1, only one overlap from S12 to S15 named as OV12. For S1 to loop line number 2, this movement will have 2 overlaps from S13 to sand hump with point number 107 normal named as OV113. From S13 to S15 with point number 107 reverse named as OV213. number 2. Preparation for route section plan for the given signaling plan with flexibility and interlocking. Route sections. In the above signaling plan, starting from left to right, route sections without points. Route section provided between S1 and S3 is named as S1 by 3 URS. Route section provided between S19 and S15 is named as S15 by 19 URS. Click on case number 8 for explanation. Though over points number 101 and 102 between signal number SH2 and signal number S4, S5, S6, only one movement is possible. For better flexibility and more effective sectional route release feature, each point is provided with one subroute separately, that is 101 A by B and 102 A by B subroute. Click on case number 5 for explanation. Though over points number 107 and 108 between signal number SH16 and signal number S12, S13, S14, only one movement is possible. For better flexibility and more effective sectional route release feature, each point is provided with one subroute separately, that is 107A by B and 108A by B subroutes. Overlaps. Down home signal number 19 will have overlaps marked as below. For S19 to main line, only one overlap from S14 to S3 named as OV4. For S19 to loop line number 2, only one overlap from S5 to S3 named as OV5. For S19 to loop line number 1, this movement will have two overlaps. From S6 to sand hump with point number 101, normal named as OV16. From S6 to S3 with point number 101, reverse named as OV26. Similarly, up home signal S1 will have overlaps as marked below. For S1 to main line, only one overlap from preparation of route section plan for double line station signaling plan. Route sections. In the above signaling plan, starting from left to right, there will be two route sections without points. One route section falling after up home signal S2 named as S2URS. Another route section falling after down advanced starter signal S15 is named as S15URS. Click on case number 8 for explanation. Over crossover point number 101 with 101 normal position, two parallel movements are possible simultaneously. Hence, all the movements over crossover point 101 cannot be in one subroute, and it is required to provide two subroutes named as 101 A by B and 101 small a. Click on case number 4 for explanation. On point number 101 for S2 and SH9 signal routes, the possible movements are: one subroute 101 A by B will be marked with two route sections 101 A toward main line and 101 B toward diversion line, and the other subroute 101 small a will be marked with one route section 101 small a or 101 small z. Over the point number 102, at any point of time there will be only one movement is possible. Over this point, the route setting will be in one subroute named as 102 A by B with route sections 102 A and 102 B. Over the point number 103, at any point of time there will be only one movement is possible. Hence, one subroute named as 103 A by B with route sections 103 A and 103b. Click on case number 1 for explanation. Over the point number 104, at any point of time only one movement is possible, hence one subroute named as 104a by b, subroute with the route sections 104a and 104b. Click on case number 1 for explanation. Over the point number 111, at any point of time only one movement is possible, hence one subroute named as 111a by b with route sections 111a and 111b. Click on case number 1 for explanation. Over the point number 114, at any point only one movement is possible, hence one subroute named as 114a by b with route sections 114a and 114b. Click on case number 2 for explanation. Over the point number 112, at any point of time only one movement is possible, hence one subroute named as 112a by b with route sections 112a and 112b can be provided. Over the point number 115, with 115 in normal position, two parallel movements are possible and which require two subroutes for the two parallel movements. Generally, we can provide subroute number 115a by b and subroute number 115 small a with route section 115 small a. But here, this route section 115 small a is combined with 112a and 112b route sections with different point setting as one subroute 112a by b along with subroute number 115a by b. By this arrangement, one subroute 115 small a is saved. Now, over point number 112 and 115, we have two subroutes, 112a by b with route sections 112a, 112b, and subroute 115a by b with route sections 115a and 115b. There will be two route sections without points, one route section falling after the home signal S20 named as S20URS. Another route section falling after the last stop signal S8 is named as S8URS. Click on case number 8 for explanation. Overlaps. Down home signal number 20 will have overlaps marked as below. For S20 to down main line, only one overlap from S19 to S15 named as OV19. For S20 up-down loop line, this movement will have two overlaps from S18 to sand hump with point number 102 normal named as OV118. From S18 to S15 with point number 102 reverse named as OV218. Similarly, up home signal S2 will have overlaps as marked below. For S2 to up main line, only one overlap from S3 to S8 named as OV3. For S2 to up loop line, this movement will have two overlaps from S4 to sand hump with point number 112 normal named as OV14. From S4 to S8 with point number 112 reverse named as OV24. For S2 to up-down loop line, only one overlap from S5 to sand hump named as OV5. (4) Preparation of route section plan for double line station signaling plan. Route sections. In the above signaling plan, starting from left to right, there is one route section without points falling after the up advanced starter signal S16 named as S16URS. Click on case number 8 for explanations. Consider the table. One subroute 101A by B will be marked with two route sections 101A towards main line and 101B towards diversion line, and other subroute 101 small a will be marked with one route section 101 small a. Over the point number 102, at any point of time, there will be only one movement is possible. Hence, one subroute named as 102A by B with route sections 102A and 102B. Over the point number 103, at any point of time, there will be one movement is possible. Hence, one subroute named as 103A by B with route sections 103A and 103B. Over the point number 106, at any point, only one movement is possible. Hence, one subroute named as 106A by B with route sections 106A and 106B. Over the points number 107 and 108, at any point of time, only one movement is possible. Hence, one subroute named as 108A by B by C with route section 108A, 108B, 108C. Click on the case number 3 for explanations. Over the point number 109 with 109 in normal position, two parallel movements are possible. It requires two subroutes named as 109A by B with route sections 109A and 109B and 109 small a with route section. Click on the case number 4 for explanations. There will be one route section without points falling after the last stop signal S14, named as S14 URS. Overlaps. Down home signal number 3 will have overlaps marked as below. For S3 to down main line, only one overlap named as OV9 from S9 to SH26, that is instead of up to S14 as it is fulfilling an adequate distance required. For S3 up-down loop line, this movement will have two overlaps. From S8 to sand hump with point number 108 normal named as OV18. From S8 to SH26, that is, as it is fulfilling the adequate distance requirement with point number 108 reverse named as OV28. Similarly, up-home signal S27 will have overlaps as marked below. For S27 to up main line, only one overlap from S21 to SH4, that is, as it is fulfilling the adequate distance requirement and free from LC gate closing named as OV21. For S27 to up loop line, this movement will have two overlaps. From S22 to sand hump with point number 103 normal named as OV122. From S22 to SH4 with point number 103 reverse named as OV222. For S27 to up-down loop line, this movement will have two overlaps. From S19 to sand hump with point number 102 normal named as OV119. From S19 to SH4 with point number 102 reverse named as OV219. Route section plan for study. Route sections. In the above signaling plan, starting from left to right, there is a route section without points provided between S1 and S3 named as S1 by S3 URS. Similarly, another route section between S19 and S15 named as S15 by 19 URS. Over points number 101 and 102 between signal number SH2 and signal number S4, S5, S6, one subroute named as 101A by B by C with three route sections named as 101A, 101B and 101C. Over point number 107 and 108 between signal number SH16 and S12, S13, S14, there can be one subroute 107A by B with route sections 107A, 107B and 108B, subroute with route section 108B. Overlaps. Down home signal number 19 will have overlaps marked as below. For S19 to main line, only one overlap from S4 to S3 named as OV4. For S19 to loop line number 2, only one overlap from S5 to S3 named as OV5. For S19 to loop line number 1, this movement will have two overlaps. From S6 to sand hump with point number 101 normal named as OV16. From S6 to S3 with point number 101 reverse named as OV26. Similarly, up home signal S1 will have overlaps as marked below. For S1 to main line, only one overlap from S14 to S15 named as OV14. For S1 to loop line number 1, only one overlap from S12 to S15 named as OV12. For S1 to loop line number 2, this movement will have two overlaps. From S13 to sand hump with point number 107 normal named as OV113. From S13 to S15 with point number 107 reverse named as OV213. Control table is a tabular representation of signaling arrangements provided for a signaling yard. The safety requirements, operational requirements, and flexibility of the movement of train are taken into consideration. The control table comprises of several columns. It furnishes the details about various operating conditions for clearing the signals or a set route. The control table or selection table for a railway station is helpful for designing its circuits. The control table is also used for undertaking functional test of various signaling functions existing in the yard. The column details that needs to be provided in selection table are shown below. Separate column is written for each subroute and overlap for same signal movements. Separate row is written for each overlap when a signal path has more than one overlap. Column number 1. Serial number. This column details the serial number of signal routes in the control table. Column number 2. Signal and route. This is written as the signal number and the route to which it is being cleared. The route can be identified as the signal to which it is leading, the road to which it is leading, or the track to which it is leading. For example, signal S1 to signal S13, a head signal number, or signal S1 to loop 1, or signal S4 to 204, or the information about alternative overlaps is also given. Column number 3. Description of main and calling on signal routes. This column details the description of the signal movement given in column number 2. Column number 4 and 5. Push buttons. Entry GN and exit UN buttons. These columns give the details of signal button and the route button to be operated for clearing a route. For example, S1 signal button GN and LP1 route button UN. In case of calling on signals where three buttons such as signal button GN, calling on signal button COGGN and route button UN are involved in clearing calling on signal, in the GN column it is written as signal button GN and calling on signal button COGGN. For example, S1 signal button GN and calling on signal button COGGN are to be written in column number 4, and LP2TUN is to be written in column number 5. Column number 6 and 7. Route sections set and eliminated en route. Column number 6 refers to the route sections to be set for clearing a signal. Column number 7 refers to the route sections conflicting to the required set route section. These are to be proved not set before setting the route section written in column number 6. Column number 8 and 9. Points set in the route and overlap. Column number 8 refers to the points required to be set and locked in route portion. Column number 9 refers to the points required to be set and locked in overlap portion. Column number 10 and 11. Track circuits free in the route and overlap. Column number 10 refers to the track circuits should be clear for signaled movement in the route. Column number 11 refers to the track circuit to be proved clear for signaled movement in the overlap section. Column number 12 and 13. Overlap set and eliminated. Column number 12 refers to overlap sections required to be set for the signal given. For example, overlap OV14, or in case of alternate overlaps OV1 13, overlap OV2 13. Column number 13 refers to the overlaps directly conflicting to the set routes sections are to be mentioned. Column number 14. Signal to danger track circuit. This column refers to the first track circuit in advance of a signal and occupation of which will replace the concerned signal to on aspect. Column number 15, approach locking track circuit. In this column, the track circuits provided for approach locking are to be proved. Guidelines regarding approach locking distances are: for mainline home in absolute block system, approach locking is considered as dead approach locking. For mainline starter, approach locking is effective from home signal if main home cleared, otherwise approach locking provided with berthing track. For loop line starter, approach locking is provided with berthing track. For shunt signal, approach locking is provided with track circuit just in rear of shunt signal. For advanced starter or last stop signal, LSS, no approach locking required as there are no points ahead of LSS. For signals which do not have track circuits behind the signal, or the track circuited portion behind the signal does not cover full approach locking distance, is considered as dead approach locking. Column number 16, 17 and 18. Aspect of signal ahead to be proved. Before any main signal is cleared, it is important to prove that the signal ahead is in lit condition. The aspects of the signal ahead are written in this column. This is generally taken from the aspect control chart of the station as shown in the signaling plan. Column number 19, a marker or CO. This column caters for information about a marker or CO on signal to be locked to assume signal to off aspect. Column number 20, position of route indicators. This column caters for information about route indicators to be lit for a diverging signal to assume off aspect. In case of junction type route indicators, for diversion movement, it is mandatory to prove that the route indicator is lit before the signal control relays are picked up for loop line movements. Column number 21, locked by crank handle group. This column caters to the information about crank handle groups to be locked for the points involved in the signaled route, that is, route, overlap and isolation portions. Column number 22, remarks. This column contains the slots to be received before the signal can be cleared. The slots can be from the next cabin, station master, from ground frames that may be controlling some points in the path of the route, line clear, level crossing gate, etc. In case of last stop signal, which depends upon the received of line clear from the next station, it is mentioned as line clear in this column. Any details not covered in the preceding columns can be written in remarks column. Conflicting simultaneous movements still possible to be locked, level crossing gate to be locked, timer release, etc. can be mentioned.
And control panel are erected as per approved plan. Relay racks distribution frames are fixed to angle iron scaffoldings insulated from the ground and sidewalls by insulators embedded with bolts and nuts. Tested with 500 volt meter to find out any leakages. Relay bases tag blocks are mounted to respective racks and tested between the tag block, relay base, fuse base to the rack. Testing to be done before later stages it will be difficult to replace. One rack can accommodate 8 major group or 16 minor group or 72 mini group in 9 rows, that is 8 groups in each row. IDF for terminating group relays. Each can take 10 numbers of 200-way tag blocks. 50 mini group terminations can be made on one IDF pillar. If more than 50 by 48 mini groups, 2 IDF pillars are required. In case of major groups or minor groups on one rack, 1 IDF with 8 tag blocks. Wiring within the group is brought to terminals of base. Terminals of all relay groups are repeated to the tag block terminal on IDF so that wiring between intergroup interact wiring is limited to MDF. Regarding point major group, the first 100 terminals, that is 1 to 100, are repeated to a tag block of 200 terminals. Remaining are not repeated as they comprise internal wiring within the group, chain group and connections to point machine. The outdoor functions pertaining to signal group and point group are directly connected to cable termination frame, that K relay. Regarding control panel wiring from panel sections are terminated to tag blocks fitted inside the panel. These tag blocks are repeated exactly in same way as on IDF. The wiring from relay rack to IDF or control panel to IDF are achieved by means of 60 and 40 core cable of 0.6 mm diameter conductors, that is 4 cable for each tag block. Since it is to repeat the terminals to their identical numbering on tag blocks, this can be carried out as soon as relay bases and tag blocks are mounted on racks. After this, belt test to check proper terminations and their soldering. Once this work is over, the free wiring, that is jumpering, is limited to the tag block terminations of the MDF main distribution frame, excepting those connected with the power supply arrangements. Incoming cable conductors from outdoor functions are terminated on 8-ways terminal blocks on cable sack designated as K1, K2, K3, etc. The terminals blocks fitted horizontally with multiple rows one below other. They are identified by vertical and horizontal row designated numerically and alphabetically and by the rack number. From the terminal block, the incoming functions are terminated to the 200 terminal tag blocks, which are fitted on the backside of the cable terminal rack. Thus, tag blocks are allotted function-wise, namely points, signals, track and miscellaneous functions, and numbered function-wise, say 500 to 599 for point functions, 600 to 699 for track functions, 700 to 799 for signal, and 900 above for miscellaneous. Here, all the terminals of the tag block are not utilized for terminating their outdoor functions. For instance, the terminals allotted to point functions will have conductor of 16-point groups only. That is, 64 terminals are utilized in the tag blocks out of 200 terminals. In other words, alternate rows of tag blocks are utilized for termination to maintain physical separation between each function. As far as possible, separate tag blocks are adopted for each relay racks, as cable can be straightaway terminated to respective relay racks in relay room. These tag blocks in the cable terminal rack are connected to the relay room by means of 60 and 40 core conductors. 24 core conductors of 1 square millimeters size for signal and point functions. Regarding power supply arrangements, separate tag blocks known as stack blocks are fitted to each rack group of the racks, which provide for 60 volt DC or 110 volt DC or 24 volt AC or 110 volt AC, as the case may be. Similarly, tag blocks are allotted to terminate the negative bias. In some places, one half of the 200-way terminal block is utilized for positive and other for the negative functions. After completion of these works, it can be processed further only after the approved circuit diagram is received. It is better to fill up contact analysis chart from the circuit diagram. This helps to know spare contacts in the group. After the contact analysis for each circuit diagram, a wiring sheet known as a jumper schedule is prepared. Jumper schedule indicates the wiring to be done from one tag block to the other tag block terminal. Color code system is adopted, assigning the particular color to denote the power supply to the circuits concerned. Not more than 2 wires terminate on the same terminals. After jumper schedules, continuity test by means of bell or buzzer. Then contact testing presence of contact as per circuit diagram is checked. For this, relays groups to be plugged in and tightly held. Types of testing. Testing before commissioning the installation. Testing after alterations are carried out to the working installation. periodical testing, technical checks, testing before commissioning the installation, testing of signal cables outdoor, testing of internal wiring, testing of earth faults, testing and adjustment of power supply system, testing and adjustment of outdoor installations and functions, correspondence test between outdoor equipment, relays and control panel, contact testing as per the approved wiring diagram, functional test of the installation, visual check of internal equipment. Detail testing. Connect the following loops on the point group base terminals 184 to 194, 181 to 191, 164 to 174. Provide loop as follows: 164 to 183, 194 to 123, 175 to 181, 134 to 121, 134 to 132. Original connections to be restored before connecting outdoor equipment. By giving loops, it is possible to get the point indications without the outdoor function units. Regarding signal and route indications, signal lamps through transformer are connected to the respective cable terminals in the cable room. Contact testing. Sheet-wise test lamp switch is connected to N60 and positive probe to fuse base lamp will glow. Remove fuse, probe is shifter to next stack block terminal in between up or down contacts to be interrupted to check the presence of contact. A thin plastic piece is used on contact pin. For parallel wiring, block parallel circuits for testing the contact concerned. Wire count testing. Maximum 2 wires on one terminal, sheet by sheet, must tally with jumpering's scheduled sheet. Circuit test, that is functional test, carried out by operating relevant buttons. Test panel with piano type buttons to simulate track circuit and miscellaneous functions. Signal lamps to outgoing cable core, point groups with loops, conducted to satisfy each column of control table. For point detection, WKR1 momentarily de-energized. If interruption is more than 2 seconds, the signal will permanently assume on aspect. GLSR to be manned for each point. Similarly for track circuits, route release by sequential track circuits, approach locking, overlap release, conflicting route section and overlaps by pressing relevant buttons. Testing of track locking. Test points with TPR up and down. Also point emergency operation can also be tested. Emergency full route cancellation test must be tested after clearing the signal for each route. If approach or dead approach locked released after time lag other than will be released instantaneously, counter operation can also be tested. Test of emergency subroute cancellation provided to cancel individual route section not released on passage of train due to track circuit failure or power supply failure. This is possible with cooperation of signal staff. Counter operation can also be tested. Testing installation after alterations are carried out. Contact testing in full where wiring has been disturbed. Functional testing. Time-consuming process panel required to be free, getting blocks and precautionary measures. Periodical testing of installation to be done to ensure that the system is working normally. Done when panel is free and will be spread over for several days. Visual check for cables, relays and relay contacts. All precautionary measures to be taken regarding safety of train working.